few days, boys and girls, we've been rounding numbers, but we've only been rounding one number before we multiply. Right now we're going to round both numbers. So go ahead and write this with me, and then you can do it in your head when we get to it, okay? So I'm going to think of 29. I'm going to round it to, and I'll round 11 to
10.
Okay, I asked you to write this, please. So 30 times 10 is 300, okay? Now, the same thing here, 29 rounds to
30.
and 20 rounds to, or 21 rounds to.
20.
So then I do 3 times 2
600.
and add 2 zeros, okay? Let's look at the next one. 29 goes to 30, 31 rounds to 30. What's 3 times 3? Okay, now starting on 4 through 11, but not 8. We're doing a different type of strategy. Apparently, I'm not the only one that thinks children need to practice their 25s. Because whoever designed this paper for practice is wanting us to take this 23 and make it a 25 instead of a 20. So we get a little extra practice with the 25s, okay? And it happens on 4 through 7 and then 9 through 11, but it doesn't happen on 8. So go ahead and write this down. So I'll take 25 times 10. What's the answer? 250. So do you see that instead of rounding that 23 down to 20, I'm actually making it a 25. Now, what reason besides we need to practice our 25s could we possibly have for making it closer to the actual?
Money.
True, okay. But if you're grocery shopping, this is my go-to example, okay? And the item costs $2.40, okay? Would I round it to $2.50 or would I go down to $2? $2.50, it's a lot closer, right? Then I might be able to buy more things with the amount of money I have. So there are times when a more accurate or closer estimate will come in handy. So if I use that same strategy here, make the 23 a 25. I'll make this a 20. Why aren't you writing this? 25 times 2. What? 50. Add a 0. Good. Right. Okay, what about 25 times 30? What's 3/4?
75.
So it'll be 75, add a 0. So what's the answer? 750. What about 25 times 40? So what's 4/4?
$1.
Okay, and add or 100 cents, right? So this number 8 is just, it doesn't have anything close to a 25. So we'll do the other strategy. It will be 4 times what? 40 times 10. So the answer is, let's not go there yet. I think we're going to get there in a few lessons, if I remember correctly. Back to the 25s again for the next 3. Why don't you try these 3 on your own?
On 9, 10.
Okay, so 9, I changed the 23 to 25. What's the answer? What's 4 times 25? 100. Add a 0. On 10, I changed the 24 to a 25. Same answer. And what about 11? Same answer. Now, before I set the timer, you'll have 4 minutes to complete it. And I helped you with the first 11. Let's go over and take a look at 23. 24. 24 would be 803. What would I round that to? 800. So I'm going to write it down to show my thinking. I'm going to round 31 to,
30.
so I have 8 times 3. 24. How many zeros? 3.
No,
So the answer to that one is,
24,000.
okay, they don't get any harder than that. That's pretty much all we have to do. Let me go ahead and, so let's take a look at the application problem for today. Go ahead and turn the page. I'm going to read it to you and then we're going to discuss a little bit. So it says Anisha is setting up a play space for her new puppy. So I've got a couple girls that aren't following along. She will be building a rectangular fence around part of her yard that measures 29 feet by 12 feet. How many square feet of play space will her new puppy have? If you have time, solve this more than one way. Okay, so RDW, what could I draw to show this play space? Take diagram.
Square.
Well, you're close.
A rectangle.
A rectangle.
So 29 and 29 and 12 and 12. And then you gotta do the
Okay, no, just a minute. Just a minute. You're getting a little ahead of me. Cooper says instead of a take diagram, draw a rectangle. Does anyone remember the name of that rectangle for 5th grade math? You got it, Rustin. You are on today. Okay, so here's the difference between the take diagram and the area model. The take diagram, I gotta be on it, looks like this, okay? The area model looks like that, okay? Go ahead and make both of them, because I want to show you the difference between the two.
Can I show the difference?
Well, no, because you were sort of on the right track, but I want to get you more on the right track, okay? Okay, so if I put 29 groups of 12 on a tape diagram, what would it look like? Cooper, do you remember?
A little bit.
Okay, tell me what you think.
So you would do, wait, are we gonna round it or no?
No, let's not. Let's just do 29.
And then you can do like 3.
Okay,
And put 12 in them.
okay.
I put 13 in.
Well, get it changed to 12. So he says do this, and that's your tape diagram. Okay, good. And we've been doing this for quite a few days, haven't we? What do we write after we draw this? What have we been writing? They're not equations.
The numbers multiplied by the.
I know, but what are those called that we've been writing for days? Starts with an M. I mean an N. Numerical.
Oh, numerical orders. Numerical numbers.
I'm a failure. Numerical expressions.
I know.
Okay.
I don't know half the names from anywhere.
Just a minute, we're videoing, okay? So I'm thinking that the two words numerical expressions have not sunk into our brains yet, okay? But what that involves is some parentheses, multiplication signs, addition or subtraction, okay? So how would I put this in one of those numerical expressions?
You would put 12.
I would do 29 times 12, and then what? 3 equal signs.
Yeah.
Okay, get that written down. This is going to be one way to solve the problem. Now, instead of 29,
30.
it's going to be 30 minus 1, right? And this has nothing to do with the tape diagram I just drew. So disregard this, okay? All right. So if I'm putting this on an area model, 29 times 12, how would I do that, Rustin?
The long part is 29, short part is 12.
Good. And this could be thought of as 29 times 12. right?
No, it should be 12 feet. You forgot to label it.
Well, I'm not going to label it yet. So this right here, I can think of as 30 minus 1, correct? Or 28 plus 1, except 28 is pretty hard to work with. I'd rather have a multiple of 10.
There's lead.
So, Jaden, we're going to get back to that question. So, as I'm doing this, I've got 2 sets of parentheses, right? And I already know that I'm going to think of it as 30 12s minus 1 12. So how do I write 30 12s?
30 times 12.
30 times 12, get to writing. And 1 times 12, get to writing. I still don't see you writing. I have excellent peripheral vision. And all I see is you playing with lead. If you want to save this lead, you can use it another time. But right now, it's not going to be in your hands. And there's how many interruptions to my video? So 30 times 12, what would it be? 3 times 12 is 36, add a 0. Minus 12. Now, in order to do this problem, I would just do 360 minus 10. And then subtract 2 more. So 360 minus 10 is what?
350.
And subtract 2 more. 348 feet squared. Okay, now Jaden brought up an interesting point. She said, I could do 28 plus 1. But my goal here is to find a multiple of 10. So you're on the right track. Let's add 2 numbers together to make 29. She already said 28 plus 1.
20 plus 9.
Okay, why is 20 plus 9 better?
Because
As a
you
multiple
can
of
round the
20.
9
Is a
to
multiple of
10
10.
and then just
Okay, so 20 is a multiple of 10. So I'm still doing the same problem, 29 times 12. I'm just breaking it apart into 20 plus 9. So this is what I have, equals, write it down. Okay, I have 20 12s plus how many 12s?
9.
9 12s. I'm going to have to write small. Okay, so 20 times 12, what's 2 times 12? 24, add a 0. What's 9 times 12? Starts with a 10.
100.
No, it's 108.
108.
Rusted?
So that was Fernando. 108, I pointed to Fernando and he answered me. 240 plus 108. I'm guessing it's going to be about 348. What do you think?
You'd be right.
Okay.
Because
So-
that's what it
Feet squared or square feet, they mean the same thing, so you can write it either way. Okay? Let's take a look at the lesson for today. This is sort of going to relate. Okay, so going down to the next one. Now what I need you to do is be careful not to write too big on the tape diagram. And remember, you wish you were me, right?
Yes.
Okay, you're going to figure that out again. So here's what I want you to do. Put 21 times 5 on a tape diagram. So what goes at the top?
25.
21 fives. And what goes at the bottom?
20
Well, how did I break 21 apart?
into 20 and 1.
I mean 21 apart into 20 plus 1. So on the bottom, this is where don't write too big. I've got 25s, right? Plus how many fives?
1 5.
1 5. It needs to be written like this. Because this is going to directly relate to our area model that we'll start using very soon, like today. Okay, so remember how you wish you were me? What if I took this tape diagram and I turned it vertical. And I transfer the information to this area model. Let's see what it looks like.
Please don't.
Yeah, you're going to love it.
Torturing us.
No. Oh, wait a minute. I want to go this way, I think.
No. Cool.
I know. Now, wait.
Oh,
I'm going to take this idea right here, sort of, and I'm going to apply it to this area model. So here's what I've got at the top. I've got 1, 5. Write it down. And I need you to make 5 boxes. Trust me, it's going to make a lot of sense when we get finished. And then at the bottom, how many 5s did I have? 3? Doesn't really matter, does it? I can draw it any way I want.
Look at our iPads.
So I have how many 5s at the bottom? 25s. Write that down. And then draw your arrow. You can draw it going down instead of up like mine turned out. Okay? And that's how you transfer this tape diagram to an area model. Now, in my opinion, this is still too much drawing. So we're going to take off a few more items, okay? How many are in each row? That goes at the top. This will be 1 5. This will be 25s. I'm done.
Fine if I erase my thing so I can fix it.
Yeah. So now I simply multiply to get my answer. Here's what I write. 1 times 5 equals 5. Go ahead and write it. And you need to know that 20 times 5 is 100. So my answer for this, I can quickly add these two together. What's my answer? 105. Okay? This is what we're learning today. These are called partial products. 5 is a product of this problem. 100 is a product of this problem. And you add them together and it's the final product for the multiplication problem. Okay, so here's what I want you to do. I want you to really pay attention here. Which number would be easiest to break apart? 31. My goal is, if I can, I want a 1 on this first, or a 2. So I'm going to break 31 apart into what? 30 plus 1. So 1 and 30. Okay? And then, what number have I not used yet? Let's put it up there. So then, wait, are you ready? 1 times 23 is 23. No reason to write that problem, is there? We know what we're doing. 30 times 23.
It's a whole different school.
So I'm going to do 3 times 3
9,
and 3 times 2
6,
and add a...
0, 9,
Okay, now add those two together. 3 plus 0.
713.
Is he right? 2 plus 9. 713. And I just added down. Now I'm not done, and I need you to listen. Okay? How does this relate to the standard algorithm I'm going to show you? 23 times 31. Now, you're used to the turtle method, which isn't a bad thing at all.
But we need to know what is really happening.
You are so brilliant. You know me too well, Jaden. It's time for you to learn what's really going on. Why does the turtle lay an egg? Okay? And so, no! I want to teach without being interrupted. Now, Mia has to listen to this.
I'm sorry, Mia.
Okay, so here's what happens on the first row of multiplication. I'm multiplying 23 times 1. And I'm going to get 23. That's a partial product. It matches my area model. Go ahead and write that much down. In the second row of multiplication, right here, where you're used to having the turtle lay an egg, we are actually multiplying times a multiple of 10, so we add a
0
to the end. Now here's the deal. You have to write the 0 first. Look at what happens if you don't. Don't write this, but just look. Let's say I did the 3 times 3 and the 2 times 3 and put my 0 on the end.
Oh my.
I'm going to get the wrong answer because my numbers are not lined up correctly. So, the reason the turtle lays the egg is because we're adding a 0 to the ones place and we're doing it first. And then 3 times 3 is 9. 2 times 3 is 6. Does the partial product match?
Yes.
What does partial mean?
Divided.
No, that's partition. Good though. Part of it. Who said part of it? Yeah. If I have a partial night of sleep, I'm not going to get a whole 8 hours, okay?
When you say partial, you really can't hear the word part, but when you spell it, you see it.
That's right. Partial, is it up there?
No. Part.
There's part of it, okay? So, here's one product to part of my, yes, and here's my second product of both that equals the final product of 713. Okay, let's try another.
Can we just do it by ourselves?
No, I want to lead you through this because, boys and girls, it gets harder fast, like the very next lesson. Okay, so here's what I want you to do. I want you to think about how would you break 21 apart and label this area model without my help. How would you break 21 apart, Jared? How would you break 21 apart? 20 plus 1. So our goal is to get the smallest number possible at the top of the area model. And what number did you put at the very top?
343.
Aren't you so glad you don't have to make 343 boxes right here?
Yes.
Okay.
Just put 300.
Now I'm going to tell you a rule right now. This will not work if you do not keep the top of the area model the same as the top of the standard algorithm.
Okay.
Okay? So it will not work. So tell me what my problem has to be.
343 times 21.
Okay, so you go ahead and give this a try. Do this area model and then wait for me. And when I multiply, boys and girls, times 20, would it be a good idea to put the 0 down first?
Yes.
Yes, it would. So keep it in the ones place so you can add this up. So 2 times 3, what is it?
6.
And 2 times 4.
8.
And 2 times 3.
6.
Okay, and I don't see any reason to add that up right now. Let's just leave it. I feel like we didn't make any mistakes, okay? Now, I'm not going to say, boys and girls, you're too old for the turtle method. You can't use the turtle method. I'm not going to say you have to use it. All I'm going to say is I want you to understand what really happens. The first row, we're multiplying times the 1 only.
Okay.
The second, oh, and does the partial product match? Draw your arrow. The second row of multiplication, what are we actually multiplying by? What number?
20.
20. So, anything times a multiple of 10 Add a 0 to the end. Keep it in the ones place. Now we'll do 2 times 3, 2 times 4,
260.
and 2 times 3, and then add it up. Oh, does that partial product match?
Yes, it does.
Regroup at the bottom. Okay, now there's plenty of time for you to do this on your own. Right now what I'm doing is I'm guiding you through possible mistakes you might make.
Okay.
All right, so one more and then today's lesson is over and you'll be able to work on lesson 5 summer. Okay, so let's take a look at it. I had to turn my page, but yours is on the bottom. So, boys and girls, have you noticed how nice and neat I'm writing?
Yes.
That's a must. You must do that. Okay? Because if your digits aren't lined up correctly, you're going to get the incorrect answer. So what number would I break apart here? 30 plus 2. How is this one different? There's no 1. I've got a 2 on the top. Okay, get it written down. What's taking you so long? So now, 231 goes at the top of the area model and the top of the standard algorithm. You know, we're not going to call that the turtle method, don't you?
Nope.
It's the standard algorithm.
Okay.
Okay, but you can use the turtle head if you want. Okay, so watch my pen here. I'm going to model how I do this, okay? You can do it how you want, but this is how I do it. 2 times 1.
2.
2 times 3. 2 times 2. Okay? Now times 3. Oh, should I go ahead and write the 0?
Yes.
Okay.
Go right.
3 times 1.
3.
3 times 3.
9.
3 times 2.
6.
Okay. Standard algorithm. What number has to go on top?
Number that's on top. The one that's on top.
Okay, so it has to match. So turtle method says I'm going to do 231 times 2 first. Don't tell me the answer. You know that's not my main goal. Does your partial product match? I don't want to know the answer. I don't want you to say the answer because you're running my lesson. And I know you don't want to run my lesson. Okay, so this time I'm multiplying times a multiple of 10 of, what is it? 30. So add your 0. The turtle lays the egg. 3 times 1. Watch how I do it. It's a method to my madness. No, I'm not crazy. 3 times 3.
9.
3 times 2. Add those up. Does that partial product match? I like arrows. Can you tell? All right. Add those up. Now, the hardest thing for children, 5th graders, to do
Remember their computer.
is to switch between addition and subtraction on these problems. That's where you're going to make the most errors. Is this what you got, 7,392?
Yes.
Okay, so